Always stay hydrated when you're doing math. What? It's the truth. Safer that way. Hey, like people. You two like ready to like do some math? Cause like today we're gonna be like combining like terms, you know. What? Not that kind of like combining like terms. It's an adjective, not noise. Combining like terms. What is a like term? You ask. Because you did just ask that, right? Because you're intelligent. What is like term? Well, like terms are two or more terms that have the same variable or variables raised to the same power. Two or more terms that have the same variables raised to the same power. Give you an example of that. You could have 4y and 3y. Same variable, y, though I write them differently. I don't know why I did that. Y. Raised to the same power. This is y to the 1. That is y to the 1. Coefficients in the front don't really matter for determining whether these are like terms. Give me another example. We could have 3xy squared plus 2xy squared. Like terms, same variables x and y, and they're all raised to the same power. X to the 1, y squared, x to the 1, y squared. You could even have subtraction in there. They're still like terms. Or you could have them in a different order. 3y squared x minus 2x y squared. You still have the same variables to the same powers. Therefore, you have like terms. Very important to be able to distinguish whether they're like terms. Wait, what was that? What are unlike terms? Well, I'm so glad you asked. Unlike terms are terms with different variables or terms with the same variables but raised to different powers. Let me give you some examples of something where that might be the case. You could have x cubed and x to the 4th. I can't put them together because they're unlike each other. They are the same variable, but they're raised to different powers. Now, one thing I want you to realize today is when we use the word combining. Combining is just a word for adding and subtracting. Adding and subtracting. We're not doing multiplication today. We're not following the power rules, and we're not finding any rules for exponents. We just are identifying which things go together, which things are the same, which things are algebraically similar enough to put together. Combine, add, subtract. We're not going to mess with those exponents today. We're just going to observe them. Thank you. Thank you. Write it in. Can you think of an example of something that just has different variables? That's easier to pick out. You have like 3x plus 7y. X and y are the variables. They're different from each other. I can't put these two things together, these two terms. I can't make this 10xy. That would be totally cheating. It wouldn't make any sense, especially if you think of x being 2 and y being 7. That 10 times x times y would absolutely make no sense. So we gotta be very careful here of identifying terms that have the same exact letters in them to the same exact powers. Or if that's not the case, determining that these things are different and they need to be left alone. They're not like each other. So let's throw up some more examples. Not throw up, but you know what I mean. Put up on the board some other examples, stuff with more things in it so we can sort these things out. This is a form of simplification sometimes, of writing things that might be jumbled up in a way that they look like they come in the same way. If you know your alphabet, That's going to come in handy today. Okay, let me give you a few hints here. For starters, write them down in your notebook. First one's right here. If we ever see a letter, a variable, all by itself, it is understood that there's like an imaginary, an invisible 1 in front of it. The number that goes in the front is called the coefficient. It just tells you how many of those things, the x things that you have. So I think for right now, it'd probably be a good idea. Anytime you see x, you should write in 1x. Anytime you see negative x, you should think negative 1x or minus 1x. That would be a good idea. The other thing is that it doesn't matter what order, that's interesting, that the letters come in. That's just one of our properties that we had before. That's commutative for multiplication. So all three of these right here are like terms. First two look the same in their letters, but not in the coefficient, as that doesn't matter. And the third one is like because it has P, Q, and an R in there. Even though they're not in the exact right order, they could be written in that order and it wouldn't change the value of that expression at all. If P is 1, Q is 2, and R is 3, I can multiply those in any order that I want to, and I still have like terms. Sometimes we want to make them look like by just rearranging the letters. That is completely legal. That is a good idea. But if one of these was r squared, then that one would not be like the other two. So don't worry about the number in front, the coefficient of a particular variable to figure out if they are like terms or not. That part doesn't really matter. That's just telling you how many of those things you have. Treat the letters, treat the variables like a word or like they're representing an object, okay? And then we're just talking about how many of those things that we do have. So I got two really basic ones up there for starters. You got 5x and 7x and 16a and 9a. And I like to call them apples or oranges or something like that. So x could represent anything. I could say I've got 5 apples and 7 apples. How many apples do I have, right? This can be simplified using math by just taking the fact that 5 and 7 are in both of those things. I can just go with 5 things and the 7 things and think about that being 12 things. Those are like terms and I have just combined them. Now, we got a difference here, but it's also combining as long as they are like terms. They have to have the same variables to the same powers. A to the 1 and A to the 1. I've got 16 orangutans. Well, that would be O. 16 artichokes. Take away 9 artichokes. It just basically turns into a 16 minus 9 problem, and with my artichokes hanging on there. 16 minus 9, 7. Got 7 artichokes. Now those are the simplest ones because they have one variable, 2 terms, and they're the same letters to the same powers. It gets more complicated though. They got a couple different problems on the board. Let's see if you can identify what's going on here. Maybe we got 3 terms and some of them are like each other and some of them are not. This is like the old Sesame Street game. One of these things is not like the other. What's like and what's not. So you look at these things, and maybe a good thing at this point would be to have out highlighters or different colors, or maybe we're just going to make different shapes around things that are like each other. One thing that I tend to do, at least in my brain, is right away put all those variables, the letters, in alphabetical order. Then it's a little bit easier to see if they're like each other or not. If there's only 2 letters, it's not so hard, but when there's a whole bunch of them, then it's probably a good idea. So I might simplify this to A, B, C, D, F, G, Q, R, S, P, Q, R, S. P goes from Q, so you leave that one that way, but I might change this one and go, that's PQ. So now I can see that this one and this one are like terms, but this one's not because it doesn't have the same variables. I can use the associative property then, and I can put the 3PQ and the 2PQ together and then have that negative 4p there all by itself because it's the one that's not like the other ones. So I've got 3 of these and 2 of these. That makes 5 of these. 5 PQs. Take away 4p, and then I stop. I don't go any further because there's nothing more to do. Those are unlike terms now, and they cannot be combined. I combine the ones that were like, but then I stopped. Know when to say no. Now look at this one here. This is an 11. Each of these has GH in it, right? So they're all like terms, right? Except this, they have to have all the same variables to all the same powers. So this one are like terms, but this one is something different. I can play the same game, and maybe I'll put the 11 in the front. Put that one next. That way the subtraction happens easier. And that maybe you might even just move this away from the other ones. Like, I'm different. I feel awkward. These two can be combined now into 8 GHs. And then you got one with FGH, and you leave it there. You stop because they're not the same anymore. They're different. Now let's throw some powers in there and see where that goes. Let's finish with these 2 examples. I'll back away, copy them down, hit pause, and then we'll talk about them. Here we go. 5, 4, 3, hit pause. 2, 1, here we go. Let's take this top one here, and some of the stuff is not in alphabetical order, so let's do that first in order to see everything, see if it looks the same. So M comes before N. That one's good, not going to change it. This one, I'm going to change to M cubed N. All right, everything else. There we go. Now, this next thing I'm going to do is this hint down here. Don't tell me that. Hang on. Okay, applying the hint. Let's put a 1 in front of things that don't have a 1. So I'll put 1 there, and I'll put 1 there. And then we see that the first one and the third one are like terms. So 2 of those and 1 of those. Yeah, I'm not even going to say the M cubed N. I get confused. 2 of those and 1 of those makes 3 of those. And then these are like terms, same letters, same powers. So we have then plus 1 of these, and 5 of these makes 6 of these. But those and these are different, so we stop because they're not the same. See that? Now the answer could have been 6n squared plus 3m cubed n, and that would also be correct. It doesn't matter which one goes first. This one has fewer. Maybe you want that one to go first. It doesn't matter. Combine the ones that are like each other. Here again, let's order them. We'll put coefficients in, and then we'll combine them. This one's fine, but I'm going to put a 1 in there. This one, I'll change the order. This one, I'll change the order. And this one's just fine the way it is. Let's find ones that are like each other. AB and AB. Put those in front. 4 of ABs minus 5 ABs makes a negative 1 AB. And then we've got these 2. They like each other, same letters, same exponents. Yes. And I'm going to go the 3 a cubed b squared minus the 1 a cubed b squared. And that makes 3 minus 1 of these things makes 2 of these things. 2a cubed b squared. And then that one, I'll put it back here. So that can be correct, or negative 1ab plus that thing would be correct. I combined the terms that were like each other, and I put some coefficients in there, and I stopped when I couldn't combine anything else because nothing else was like something else. You know, it's like pretty straightforward. Well, it's not, but that's why we're going to practice. Okay, I'm there for you. I'll practice with you, do some other ones. That's confusing, and you'll get this.